Okay guys, welcome to today's video. It's been a long time since we did some math, so today we want to continue looking at the relationship between sides and angles. So I've found these good questions here. We're going to do 3 examples on Pythagoras theorem and the trigonometric ratios. So this is on trigonometric ratios, the ones that we started looking at in the previous video, called the SOHCAHTOA. So we want to see how we can apply these into different mathematical problems. So there is this triangle here, which is right angle triangle. It says calculate the value of x. Now this value of x is the angle. So they are asking us to find the value of this angle, which is labeled as x. Now, we need to look at the given sides. We've got this side here and that side there. Now, we said to determine what sort of side we've got, we need to make reference to the given angle. So we've been given this angle x here, and then that means this given side here, which is 4 centimeters, is the opposite. And then the longest side is always the hypotenuse. Now, before we do anything, we need to look at the 3 trigonometric ratios that we have and look at the one that has got the opposite and the hypotenuse. And then you can straight away see that we've got the sine ratio. So if you remember very well, we said sine theta, all right, is always opposite over the hypotenuse. Now the theta in this case is the x that we've been given here. So it is as good as saying sine of x of the angle is always going to be equal to the opposite over the hypotenuse. So now what we need to do to find the value of x is to substitute 4 where there is O and then 7 where there is h. So we're going to say sine theta, which is sine x in this case, would be equal to 4 divided by 7. Now what this is going to give us is the ratio, but we want to find the x. All right, now to do that, you need to say x, which is going to be the angle in this case, would be equal to sine inverse, okay, the sine inverse of 4 over 7. Now someone might want to know, how do we find the sine inverse here? On your calculator, you are going to go where it says shift or the second function. All right, so on top here, top left corner, there is what says shift on most of the calculator. You punch on shift, all right, and then you go on the button for sine. When you do shift, it will give you the sine inverse. So once you do shift or second function, you go on the button that says sine. It will give you sine inverse, and then you put sine inverse of 4 over 7, which means now that the calculator is going to give you the angle or the value of the x. So if you do sine inverse of 4 over 7, you should be getting 34.8 degrees. All right. If you are a Cambridge international student, they require that angles are written to 1 decimal place. So this obviously gives us 34 point something something, but then written to 1 decimal place, we would conclude that our angle is going to be equal to 34.8. So I'm going to emphasize on the need to know how to do the inverse. Okay, so we've got sine x equals to 4 over 7. This is not the value of the angle. To find the value of this angle here, we need to say x would be equal to the inverse of the function, which is sine now. So you are going to do shift or the second function and then press on the sine function. So it will give you sine inverse of 4 over 7. If you do that nicely, you would get the angle once you do your equal sign. In this case, the angle gives us 34.8 degrees. If this was a cos function, we were still going to do shift and then press on the cos button to get the cos inverse, and then whatever ratio that we've got to get the angle. So guys, let's look at the second example and see how we can use these trigonometric ratios. Okay guys, so this is our second example. All right, we've been given this triangle here, and then the question is 2 marks. It's a very simple concept to take note of. It says we've got the triangle, which is right angled triangle, because we can see that. All right, this triangle ABC, the longest side is given as 3.5, and then one of the sides is given as 0.9 meters. Then the question says calculate angle BAC. BAC meaning this angle here. So I'm going to call angle BAC theta, for just so that we can just easily work it out. So this angle BAC, this angle would be called theta for my calculation. So we are still looking at this common concept, which is called SOHCAHTOA. Okay, it's just a short way of us remembering what sides to divide by, or what and what. So now the question is, before we find the value of angle theta, we need to look at the sides that we've got. All right, if the angle that they are asking us is this angle here, which is BAC, then this should help us find or name our sides. So you know that the longest side will always be the hypotenuse, and then we need to know this side here, which is BA. Because it is next to the angle, this will now be called the adjacent side. All right. So now on our 3 trigonometric ratios, we need to pick a trigonometric sign or ratio that is going to have the adjacent and the hypotenuse. If you look at that nicely, it's the cos, because cos uses the adjacent and the hypotenuse. So it means we're going to have cos theta, which is the angle which they want, these guys, would be equal to the adjacent divided by the hypotenuse. So we need now to ask ourselves, what's our adjacent? Our adjacent in this case is 0.9. So we're going to say cos theta would be equal to 0.9 divided by 3.5. Okay, so if you do that, you don't really need to divide that. All you need to do is say, because I'm looking for theta, I'm going to say theta would be equal to the cos inverse, like we did on the sine. So you go second function, then the cos button to give you cos inverse of 0.9 divided by 3.5. You can write this as a fraction. If you do your working nicely and you got your calculator, you are going to get that theta would be equal to, let me just look at my working here, 75.099 and so on and so forth degrees. Now, under the Cambridge or the Zambian syllabus, they say angles should be written to 1 decimal place. Okay, so this means now that therefore our theta, which is now angle BAC, all right, would be given as 75.1 degrees. So that means you found your angle there. So guys, I'm just going to emphasize on this cos inverse here. When you are finding the angle, you need to use the second function of the same trigonometric ratios. So in this case, it's cos, so we want to find the value of theta. We need now to say theta would be equal to the cos inverse. How you get the cos inverse now is going on your calculator and look at the button top left corner, which says shift, or on other calculators it says a second function. All right, then once you press on that button, you go back on the trigonometric ratio. If it is sine, then it will give you sine inverse. If it's cos, it will give you cos inverse of the same ratio that you've got there to get the angle. So it is very important that we get used to these questions. So guys, please like and share my page or my YouTube channel, which is Math Antenna. It goes by the same Facebook name. And then please watch out for 3 more examples on trigonometric ratios, so that we can finish this concept and start looking at other 9 right angled triangles that do have other concepts. So thank you very much, and God bless.